Okay, so in the last video we learnt about what is arguably the most remarkable graph in all of astronomy, the Hubble law. This very weird relationship that everything is moving away from us, but the speed at which it moves depends on where it is. It's proportional to its distance from us. So how could we possibly explain this?
Well, some people write into me, and I get a lot of email on this thing with their own theories. And the favorite theory that's mailed to me is what I call the exploding egg theory, where you go through and you have an explosion with things being thrown out in all directions. Paul, you've simulated this, haven't you?
Oh, funny you should ask that. So here is my simulation of the exploding egg model of the Big Bang. This is not what we currently think, but let's just explore the consequences of this idea. So the idea was that once upon a time, long, long ago, there was a big, dark, empty universe, and in the middle of it was an egg. And one day, the egg went bang and squirted out galaxies. In this highly sophisticated simulation, I've just had spheres to represent galaxies, but you get the idea.
So everything's moving out, and we're here in the center, I suppose. And we look out, and we see things that are moving slow or nearby, because they haven't gone very far since the explosion. And things that are a long ways away are, of course, moving very quickly. That's why they're a long ways away. Well, it seems almost perfect.
That's like getting the Hubble law for us.
Exactly, but there's maybe a problem. I look here, and I see there's all sorts of stuff nearby. And when I look a long ways away, there's only a little bit of stuff. So that would mean that if I look out in the universe, I should see a lot of stuff nearby and not very much stuff far away.
Which is not what we see at all. As far as we can tell, at all distances you see about the same amount of stuff.
There's another problem. There would be an edge to the universe, that place where we wouldn't see anything at all because the stuff hadn't got out there, even the stuff maybe that was traveling near the speed of light.
Well, I think I can fix the problem of having too much stuff in the middle. The reason in this simulation why there's too much stuff in the middle is because I had a fair number of slow galaxies and not so many fast galaxies. So let me run a simulation with lots of fast galaxies and not so many slow galaxies and see what we get. And here it is. Bang!
All right, so let's see. This one looks a little different. So in this case, all the galaxies are in a shell. It's like a blast wave or something, but there's not much stuff inside. So we'd still be in the center of this one, and we'd look out, and we'd see all this stuff in all directions, moving a long ways, moving quickly away from us, but we wouldn't see anything nearby, would we? It would be sort of empty, and so you'd see sort of this ring of material moving fast, but you really wouldn't get the Hubble law in the same way that Hubble got.
Yes, and when you look at some of the deepest observations ever made of the universe, in this case taken with the Hubble Space Telescope, named after Edwin Hubble, here we're looking at some ground-based images of part of the sky just near Orion, and we're going to zoom in on this incredibly deep observation through a series of images. What you'll see here, as you look out to distances of 10 billion light years, is galaxies that look very much like our own. We seem to be still seeing uniform density of galaxies nearby, 1 billion light years away, 2 billion light years away, 3 billion, all the way out as far as we can see, which is about 12 billion light years. The universe looks very uniform.
So we're zooming into the deepest image ever taken by the Hubble Space Telescope of a tiny little piece of sky, 1/32 millionth of the entire sky. And we see galaxies spread across the sky and sort of at all distances between us and 12 billion years into the past. And the amazing thing is if you look this direction and you look that direction, the other side of the sky, you see exactly the same thing.
So this exploding egg model has trouble, really. It makes us in a very special place, and it really suggests we should see either a concentration of galaxies around us or a shell, and there should be, when we go far enough away, nothing beyond that. That's not what we see at all. What we see is we seem to be in a very ordinary part of the universe. We see the same density here as we see out to colossal distances in any direction as far as we can see.
So that seems to indicate to me that Copernicus was once again probably right.
We're not anywhere special. I think we need a new theory. And that's what we'll cover in the next video.